Hello, welcome back to another video on YAGSL. And in this video, I'm going to show you how to tune your PID using YAGSL and simulation. Sorry if my voice sounds a bit, okay, I'm a bit sick. Now let's get started. First, we are going to go download we're going to download AdvantageScope. And so you can go click on the documentation here, and then you go to download links, and this should take you to the most released one. And here's all the links. Click on whatever one you need. PID stands for proportional integral derivative, and by changing these three values right here, we're able to make our robot's movements more precise and consistent. And this is useful in, say, teleop or autonomous, as we want our robots to have accurate movements and not be as unpredictable. So the P basically stands for if you're not there, get there. The I is by basically saying the point you want to get to. If you're far away from that point, you want to speed up. And then the D, if you don't want to overshoot this target if you're going faster. So D is basically saying, hey, if you're close to your target, slow down. And so in this tutorial here, we're going to be showing you how to basically tune these values using our simulator in YAGSL. So we're going to open up VS Code here. And first things first, we're going to go to our Swerve subsystem. In our Swerve subsystem, I want you guys to type Swerve drive telemetry.verbosity is equal to telemetry velocity.high. And what this does is it's gonna basically output your like a bunch of data for your robot's like movements and its like positions trying to get to. This is useful for us when we're trying to tune PID, as we want to know what our velocity is, or which way our motors are moving, compared to, say, what we want it to be. However, I will say, when you're at competition, make sure you turn this to low, or just like get rid of it entirely, as this is going to make your robot run a bit like slower, as it's outputting a lot of data. And with that, we can start going to our AdvantageScope. So we're in AdvantageScope here, and what we need is to get our line and swerve graphs. And to do this, if you don't already have it, is you're going to go to this plus sign here, click on line graph, and click on swerve. Basically, you get these two graphs, and yeah. So we're going back to VS Code, and we're going to start simulating our robot code. So we're going to simulate robot, and it's going to build. We're going to let it build. I'm going to pick Sim GUI, and then ta-da. And so what I'm going to do is make our robot simulation basically take up about half my screen. I'm going to clear up some of this junk that is on the screen, actually, because we're going to be rebooting this thing a lot, and we don't want so much unnecessary clutter, as we're trying to test a robot here. I'm going to put this here. There we go. Nope. This. Awesome. So now we have our robot's code, and it's moving. Oh, by the way, compared to the other tutorials, I made this robot a lot faster by going to your constants and just changing my max speed to be higher and in meters instead of feet. Okay, so we're on our simulation, and we're going to go back to our AdvantageScope, and we're going to go to File, Connect to Simulator. because remember, we have our simulator in the background, and now it's moving a lot. But if you notice, there's not any lines or anything, and if we're moving our robot, it's not outputting any data. Why? Because we haven't told it what data we're looking for. And so we're going to do that by searching raw drive velocity, and we're going to take the back left one, right? We're going to take this and basically drag and drop it here, and we're going to take our set point and drag and drop it here. So what are you looking at? Well, the speed set point here is basically your ideal movement, right? The position you want to be in. The raw drive velocity is what you're actually moving, right? So this is the value we want to change. And the goal of PID is so that when we're moving our robot here, let me show you. We're moving it around, and we want it so when we're moving our robot, these two lines are right next to each other, or basically overlapping. And this is our swerve widget, right? And we are going to do the exact same thing. So let's go to this one. We go to swerve. Let's do advanced right here. So we're going to type swerve, and then it's going to bring up here. We're going to take our current state, desired chassis state, desired state, and measured chassis speed. And this here does the exact same thing as our linear graph. And so when we're moving, we see all these arrows. And the goal is so that these arrows are overlapping as much as possible. Because that way, our desired state, our desired movement, and our actual movement are exactly the same. Okay. The first step to tuning your PID is to locate your PID config file, which is right here, PID properties.json. And in this tutorial, I'm going to be showing you how to tune it manually. However, YAGSL the documentation does provide starting values that do work if you're using like the robot weight that was provided here. However, if you're actually tuning this for your own robot and you are probably going to have to tune it manually, and these starting values are probably not going to help. And so I'm going to be starting from 0, and we're going to pull it up in our simulation here. So I'm going to simulate robot code. Simulate robot code. Yep, there we go. It's building. Sim GUI. And then I have, is it frozen? Okay, it's not. If it's frozen, just like reinstall it. And we are going to teleoperate it. And we're going to get some data. We're going to move our robot around. Wiggle, wiggle, wiggle. Ooh, it's wiggling. There we go. And over here, we have our orange line and we have our blue line. Our orange line here represents our set point right here. And that is our desired location. The blue line represents our actual velocity, our raw drive velocity. And this blue line here, we want it to be matching the yellow line right here. And to do that, we're going to be tuning our PID based on what we see here. And so they say start at 0 and slowly increment up till it starts oscillating. I see here it's already kind of close, but it's kind of undershooting a little here. So I'm going to do 0.5 0.002. And then I'm gonna restart it right here. And then teleoperate. It restarted again. So now I'm just gonna drive this. I'm gonna delete this. Clear. Okay. Driving. And it looks like I'm okay. Looks like I am getting a little bit closer. Although, yeah, see here. Although I prefer if it is a little bit more. Okay. Let's go here. And I'm just gonna improve. I like it at 2. Maybe I could do 0.205. And yeah. So how much you increment by is basically up to you. You look at your graph and you see how the blue line is compared to the yellow line. So if the blue line is above the yellow line right here, your velocity is over your desired. That means your PID is overshooting. Whereas if it's under, that means it's undershooting, right? So if you have like a mixture of both, like here I have it going up and down, I think it's time to start adjusting my PID, or not my PID, just like the D value of it. But yeah, I'm gonna do it relatively quickly as the process of tuning it to absolute perfection will take eons, and I think you guys can figure out how to increment your numbers by decimal points on your own. As I'm gonna move on to the D. So D is for kind of like stands for how much you want to decrease by, and I'm gonna do 0.02. It's kind of like where I like to start off. Let's see how good enough we're gonna get it. Ooh, it's still overshooting a lot. Okay, so there's a gap. There's a lot of gaps here. Click on the point. Let's look at swerve. Okay. So what does this mean? I think we should increase our D. Or, yeah, because it's overshooting a lot here, you see? And, okay. So when the line is overshooting, you either decrease your P or increase your D. And then the inverse is obviously true. If you're undershooting, you want to either increase your P or decrease your D. You really don't want to touch it unless absolutely necessary, or F. I'll look into more of that if you feel like it. But basically, it's kind of like last resort. If your P and I or your P and D is not working, you want to increment your I and F to like a little bit. So you're gonna restart, teleoperate, and over, under. Let's see. I'm still not actually. It's like lining up perfectly, or as I like. Maybe I increase my P a little bit since I'm like undershooting here. Yeah. Let's increase my P to like a couple of decimal points. Teleoperate. I think I'm overshooting actually. Yeah, I'm overshooting more. Undershooting? Let's see. Yeah, maybe I should increase my D in this case. Once again, this process takes forever, and to be honest, it's going to be a lot of work. Alright, here's that autonomous. Woo, I undershoot that a lot. Okay, maybe I increase my D instead. Or my P. Yeah, oh. Okay, I'm undershooting a lot now since I increased my D. So, I think I'm going back to increasing my P instead, actually. Yeah. Maybe I'll put a 2 here. Oh, not there. Here. So, yeah, the process of tuning your PID is look at your graph, test it. If the blue line is above the orange line, you're probably overshooting. Like here, this is clear overshooting here. So it looks like when I was closer when I was with the 0. And then if I go back here, change this back, maybe change this to a 1 instead. We go back, change our values, look at the graph, operate, and okay, we're kind of oscillating here now. Look, we're kind of on the line, and we're going bit below, bit above. Yeah, okay. You can definitely get it more precise than that, but I'm gonna keep it like that. I like that. It's still undershooting a little bit, so let's decrease our D. Very, very monotonous process, I'll tell you. Okay, now we're overshooting a lot, so maybe I should have. Yeah, okay. Yeah, we're overshooting here a lot. I'm gonna keep my D at like 50 then. Now let's see how that is. Oh, I need to restart your simulation. Teleoperate. It's overshooting. Yeah. This is overshooting. Overshooting. Awesome. So we're gonna increment that to 3. Restart. But I hope you guys see the drill now. It's gonna be a lot of back and forth testing. If you're doing this with a actual robot, you're gonna need definitely a lot of space to test all this out. Luckily, though, simulations and physics simulations allow us to do it in the comfort of our own homes. I think this is the closest I'm gonna get for today. All right. So you can get it a lot more precise than this, but of course, it's gonna take a lot of trial and error and a lot of testing. But yeah, that's how you are going to be able to tune using our graphs here. Oh, and here's our swerve module if you want to see that. It's slightly better. Yeah, so you want these lines to overlap as much as possible. I think the odometry made it so it's like all confused. Ooh, there we go. Yeah, that's gonna be the end of today's tutorial. I hope you enjoyed it, and Hope you now understand how to tune PID using your simulations, and yeah, happy swerving.